such that the tension will be 0 here. Like this. So when it reaches to the highest point, the force will be acting always vertically up. Okay, look at this. This will be string. Now, what is the condition I'm giving? The force F1 will always act vertically up on the bob. This will be F1. This will be weight. At all the positions. So even if you want, I'll give one more. This will be the condition. So I'm just asking you, what is the, well, where is the critical point? Where is the critical point here? So we'll do one thing, write equation. Here the velocity of the bob will be, say, V1. This will be V2. Okay, let's write at point 1. T1 plus F1 minus mg equal to mv1 square by L. At highest point, T2 plus mg minus F1 mv2 square by L. And I'll put F1 greater than mg until where the critical point will come. It all depends on that situation. If F1, first case, I'll write it. Let F1 greater than mg. Where the critical point will be? Where tension can be minimum, T1 can be minimum here. T1 can tends to 0. Then we'll provide required centripetal force F1 minus mg. Here if you put select F1 greater than mg, if tension becomes 0, tell me, I think not possible, no? There won't be centripetal force to complete the circle at the point 2. Are you getting, no? I'm putting F1 0, and if you put T2 0, I think not possible, no? There won't be force that will be acting towards the center. So where is the critical point now? If F1 greater than mg, where the critical point will come? At the point 1. So this should be the minimum velocity now. So what is the expression for this one? So point 1 will be critical point. The lowest point itself will be critical point. So nothing. So don't say that at highest point it should have root GL to complete vertical circle. That is not correct. So what you should say, at critical point it should have critical velocity to complete circular motion. And where the critical point? In the normal problem, first introduction I made it, the critical point was at highest point. That's all here. So now where is the critical point now? This is the critical point here. The critical point is here. Now if let F1 be less than mg. Let F1 equal to less than mg, that one. Then I think now where do it will come? So here T2 can be 0. If T2 tends to 0, then we will provide required centripetal force, the resultant of mg and F1. And here V1 will be minimum. Here V2 will be minimum. And now tell me, like, what is the critical point now? Point 2 will be the critical point. 2 will be the critical point here now. Point 2 will be, this is very important analysis. When it comes, the critical point is what? Very important. And this V2 is minimum, nothing but you have to call that as critical velocity. Getting the idea? So now in the first case, when F1 greater than mg, the critical point it lies at the lowest point. When F1 greater than F1 less than mg, no, then the critical point open will shift to the highest point here. So I think I discussed almost all the possible situations that are related to critical point. At critical point, it must have critical velocity. And now, sir, I want the expression for what is the minimum velocity. I should project at lowest point. You are at lowest point only, and there the critical point lies, no? So with what speed you should project? You should project with a speed v1 at the lowest point, the first situation. It will complete vertical circular path. Okay, got this? So when let f1 less than mg, then you have to calculate. You calculate at speed v2. You know minimum velocity. Work done by f1 and tension will be 0, no? Apply conservation of mechanical and you calculate. Able to make it out? This one. So this is the for second situation. We have to write equation now. mv1 square by 2 is equal to mg into 2l plus mv2 square by 2. And what is v2? Substitute that v2 here. Solve for v1. You'll get v1 in terms of f1. What minimum velocity you should project. I think everyone is able to understand at least what do you mean by critical velocity here. So I'll take it out, because again you think that because I discussed two cases, no, I'll let me not write. Okay, I'll proceed now. So we'll take the idea of the springs. So already we discussed in the laws of